Hello everyone, I'm Karthik Gurjar. Today I'm presenting our internal test analysis which focus on understanding statistical dispersion and feedback data. This presentation covers detailed solution for question 1 and 2 and it is submitted to Dr. Shaligram Prajapat sir. Moving on to the first slide. Characterizing dispersion. Let's start with question 1. We were asked to identify three statistical measures to characterize the spread and dispersion of student feedback data. The three most common measures are range, the simplest measure which is just the gap between the maximum and minimum scores. Second, the interquartile. This measures the spread of the middle 50% of the data effectively ignoring outliers. Third, standard deviation, the most widely used measure which calculates the average distance of every single score from the mean. We also analyzed how to compute this efficiently in large datasets. Range is very fast because database can retrieve max and mean values instantly without scanning every row. A standard deviation is also efficient. It can be calculated in a single pass, big O of n complexity by keeping running totals. IQR is tricky one. An exact calculation requires sorting the entire dataset, which is slow. In big data, we often use approximation algorithms like t-digest to estimate it quickly. Moving on to the question 2, we were given a specific data set of feedback rating from 27 students regarding faculty mental. The scores are already sorted from 13 up to 17. Having sorted data is a huge advantage for calculating percentiles and medians manually. We calculate the basic central tendencies measure. Mean we sum all scores which is 809 and divided by 27 giving us an average of 29.96. Median the middle value which is 25. Mod the most frequent scores are 25 and 35 making this a bi-model distribution. Mid-range the average of the highest and lowest is 41.5. Quartiles and five numbers summary. Next, we look at the spread through quartiles. Quartile 1, first quartile. This is the middle of the bottom half, which is 20. Third quartile. This is the middle of the top half, which is 35%. This gives us a five number summary. Minimum is 13. Quartile 1 is 20. Median 25. Third quartile is 35 and maximum is 70. This snapshot tells us exactly how the data is distributed. Quartile plot versus quartile plot. Quartile plot. This graphs the actual scores against their rank percentage, 0 to 100%. It shows us the specific shape of our data. Quartile plot. This compares our data against a theoretical distribution like the normal distribution. It helps us answer the question: Is our data normal? The next slide. Why is the quartile plot so powerful? It gives us a visual truth test. If the points fall on a straight line, our data matches the theoretical distribution. If the points form a curve, it indicates our data is skewed or different from the theoretical model. Summary and key measures. Mean is our average, but it is sensitive to outliers. Median is the middle value and is robust against outliers. Dispersion measures range, IQR, and standard deviation. Tells us how spread of out the feedback is. Mode highlights the most common student opinion. Now moving on to the conclusion. First, review. We must master central tendency and dispersion. Second, apply. We should practice this calculation on new dataset. Third, and last, explore. Explore. We should use visualization like quartile plots to validate our assumptions about the data. Thank you for listening.